In this video, I'll show you how to configure your own personal VPN using a Raspberry Pi. It's a perfect setup for traveling, working from coffee shops, Airbnbs, hotels. Not only will it connect you to your internet, but it also gives you full access to your home network, your databases, web servers, and media. I'll walk you through the step-by-step configuration for your phone, your laptop, and your travel router. By the end of the video, you'll have the infrastructure to physically work from anywhere in the world while looking like you're right at home. First up, you're gonna need a Raspberry Pi with decent RAM, USB ports, or a micro SD card reader, and a reliable Ethernet connection. For this project, I'm using the KNKit Raspberry Pi 4. It packs 4 gigs of RAM, 64-bit quad-core CPU, micro HDMI port for display, USB-C power, and full gigabit Ethernet. Next up, you'll need a travel router. I'm running this portable gl.inet router. Hardware-wise, it gives you 3 gigabit Ethernet ports, a USB 3.0 port, and solid dual band speeds. What really makes this perfect for travel is that WireGuard and OpenVPN come pre-installed out of the box. It functions as a public Wi-Fi repeater and even has a kill switch feature to block unencrypted traffic if the hotel connection times out on you. It's incredibly light and small and built for on-the-go setups. To get Linux up and running, we're not going to deal with the traditional installer menus or ISO files. Instead, we'll use the official Raspberry Pi imager to flash the operating system directly onto our micro SD card, and in this case, a USB drive. Go ahead and pop your USB drive into your computer and open up the imager app. First, click on Choose OS. Select Raspberry Pi 4 for your device. Next, in the storage, select your USB drive from the list and enter the hostname. For the localization, I'm going to choose Washington, D.C. and the time zone to Los Angeles and the keyboard layout to the US. Now choose your username and password. In my case, I'm not going to set up a Wi-Fi because it's already going to be hardwired via Ethernet. For customization of the SSH authentication, enable SSH and use password authentication unless you prefer public key authentication. That works as well. By baking these settings right into the USB drive, we completely skip the need to hook up a dedicated monitor and a keyboard to the Pi later. What we'll end up doing is SSHing into the Raspberry Pi. Once that's set, hit right and let it flash the USB drive. Once the imager finishes verifying, eject the USB drive and slide it right into the slot of your Raspberry Pi. Connect your Ethernet cable directly to your router or switch for the best possible speeds, and then plug it into the power cable. On the very first power up, there's no manual installation wizard for you to click through. The Pi boots straight from the USB drive, automatically expands the file system, and configures your user accounts in the background. With the Raspberry Pi running silently in the background, we can head back to our main computer to log in. Open up Terminal or PowerShell window and SSH into the Pi by typing SSH, your username, at the IP address of the Raspberry Pi. Punch the password you created inside the imager, hit enter, and just like that, we're standing right inside our Raspberry Pi. So now we can configure PiVPN, and the first part of that is to run the installer. And then you choose the user, and afterwards you choose WireGuard as your VPN protocol. I like WireGuard because it's one of the fastest protocols currently available. Here you can choose your port. I typically just leave the default port. Then you choose your DNS provider, and in this case I'll use Google DNS. You can assign the public IP address of your network, or you can give it a DNS name. Right now I'll use the public IP, but I do plan to update this later to use the DNS entry. Yeah, and that's pretty much it. One thing I'll say is that you want to reserve the IP address currently on your server running the VPN so that it doesn't change. You might also need to reboot. And once you reserve the IP address, you can update the router to forward VPN traffic to your Raspberry Pi or whatever server is running VPN. Now what we'll do is configure port forwarding. By default, routers block incoming traffic for security measures. So we have to explicitly tell our router to let the VPN traffic through. Every router interface is a little different, but I'm using the E-roll setup for this demo. Inside the app, I'll select our Raspberry Pi, enter the default WireGuard port 51820 and give it a name. If you change the port number during the setup, just make sure you use that number instead. Once you save it, any traffic hitting that port will be safely directed to your Raspberry Pi. Let's create our VPN client. SSH into your Raspberry Pi server and add a VPN profile that you'll use to connect to your home network, then enter the name for the client. You can download the client configurations in this directory. You can also generate a QR code for your clients. This comes in handy when you import the configuration to your phone using the WireGuard app. Then you can add the configuration using the QR code. You can create multiple profiles for different devices. At this point, let me show you how to configure your WireGuard VPN on your phone, laptop, and router. So we'll start with the simplest setup, which is the mobile phone. First, go ahead and download the official WireGuard app from the App Store. And at this point, once it's installed, you can head back to your computer, remote into your Raspberry Pi. Since we already created a client profile, we can generate a QR code for it instantly by typing PiVPN-QR. Now select your phone's profile. A massive QR code will pop up right there in your terminal. Now you can just open up the WireGuard app on your phone and tap the plus sign, select scan from QR code, and point the camera at your computer screen to import the configuration. And that's it. You're fully configured after it's been successful, and you can toggle your home connection on and off with a single tap wherever you are. Now let me show you how to configure your MacBook VPN. Again, download and install the WireGuard app. And the first thing you're going to want is the configuration. You're going to need to download it to your computer. So if you open up this desk and download the configuration file, since it's needed for the laptop and the router setup. Now that WireGuard is running, click on Manage Tunnels. Then you can import the tunnel by importing the configuration file. You can activate or deactivate the VPN or your connection to the VPN from the app or the quick launch. To really understand why this setup is so powerful, let's look at exactly what happens to your data when you're sitting at a coffee shop. Normally, when you connect to the public Wi-Fi and look up a website, your traffic is sent out into the open. The coffee shop router, the internet provider, anyone snooping on that unencrypted network can see exactly what you're doing. But with your personal WireGuard VPN turned on, everything changes. The second you hit enter on your laptop, the WireGuard client instantly encrypts your data. It wraps it in a secure cryptographic tunnel. When that data leaves your laptop, the coffee shop's public Wi-Fi can't read it. All they see is scrambled, unreadable gibberish traveling to one specific destination, which is your home IP address. The traffic travels across the internet and hits your home router. And thanks to the port forwarding rule that we set up earlier, your router sees that traffic arriving on port 51820 and says, I know exactly where this goes, and passes it straight through the firewall. Finally, the Raspberry Pi packages the response back up, recrypts it, and sends it right back through the secure tunnel to your laptop at the coffee shop. You get full unrestricted access to your home network and a completely secure connection to the public internet, no matter where you are in the world. Time for a field test at Starbucks. Let me show you how to connect your laptop to your personal VPN. The first thing I'll do is connect to the Starbucks Wi-Fi and register using the captive portal. Now that I'm in, you'll notice I have access to the internet, but don't have access to my home network. For this reason, I can visit yahoo.com, but I can't access my Jellyfin media server at 192.168.4.80. To get access to my internal network, I'll activate my house VPN profile, which will enable my connection to my personal VPN and give me access to my resources. As you can see, I now have access to my Jellyfin media server. Now let's say I want to connect to one of my file servers where my media is stored. I can connect to my file server and open up those files. So if you look behind the window, I also have access to the Postgres database. Now let me show you how to configure your travel router. I have my router connected to my Ryobi inverter discreetly tucked inside of my laptop bag. Change your internet connection to the gl.inet Wi-Fi. The router doesn't have an internet connection to repeat, so you won't have access to internet. So let me show you how to configure your router with internet so that it can repeat it to your users. To access the router, head to the default IP address. For my router, it's 192.168.8.1. Then head to the internet section. Click on switch network and find the Starbucks Wi-Fi. After it connects, you'll have access to the internet. If you don't get the internet access, it might be because the captive portal agreement has not been accepted. You can head to apple.com using HTTP, not HTTPS. The insecure site should redirect to the captive portal for registration. As you can see, I now have access to the internet through my travel router, but not my home network, or else I would have access to my Postgres database. What you'll need to do is head to the VPN dashboard and enable the VPN profile on your router. A good sign is seeing the traffic stats. As you can see, I'm connected to my travel router Wi-Fi. If I refresh my connection to Postgres database, it turns green for successful. I can also query the database. I can also connect to my servers to get access to the content, or in this case, my music. I can also reach my internal Jellyfin server at 192.168.4.80. If I need to manage a server, I can SSH into the server successfully and restart services, update config files, and more. At this point, your public IP will be your home network public IP. You will have access to your content, Ubuntu services, and databases. So this is helpful if you're a content creator, someone doing film, because you're able to VPN into your home network and from your laptop and view video, images, or any content in your NAS or in your servers. You can also back up your data from wherever you are to your NAS. I find that the phone VPN is also helpful at times if you're places that are just boring, like in the waiting area at the dentist. You can VPN from your phone and then review your footage from your studio. Now you can look at all of your content in your home studio, your home network from anywhere, whether you're at the dentist waiting room area or bored at the DMV. It's the ultimate infrastructure for working on the road. So at this point, I've shared with you guys how to configure a WireGuard VPN and how to connect your phone, your laptop, or your travel router to your VPN so that you have secure access to your home network from any part of the world. Most VPN providers don't give you access to your home network resources and charge you a monthly subscription simply to hide or to protect your traffic. This does that and more. This helps you function in the same way that you would if you were working from home. So hopefully this helps, and I'll catch you guys on the next video.